Hello, everyone. My name is Xin Yang. I work for Huawei on OpenSDS. I'm also a contributor in Kubernetes and CSI. I work with Jing on the Snapshot feature. 大家好，我叫杨欣，我在华为工作。我和徐晶一起做 Snapshot feature.
Hi, good afternoon, everyone. My name is Jing. I work for Kubernetes storage lifecycle team at Google. And Xing and I are co-lead the CSI Snapshot project. Here we are presenting our project. 大家下午好，我叫徐晶，我在谷歌。今天我和新阳呢，给大家介绍我们的 CSI Snapshot project。我们用英文来介绍，但是呢，也欢迎大家用中文来交流和提问题。Hi, Xing, do you use cloud in some way?
Yeah, I put lots of my data in the cloud. My photos, videos, music, all uploaded in the cloud. It's very convenient. Even this slide deck is in the cloud. So I can just use it whenever I want to.
True, but it's really safe upload here?
Yeah, I think so. Well, until it rains.
Oh, great. Thank you for reminding me that. I think we do need rain very badly in California right now. Okay, back to the topic. Just like it might rain like anytime, right? Like errors, failures, problem issues might happen at any moment, any place. So how we can protect our precious data?
Snapshotting is my choice. It's easy, cheap, and fast. I can easily restore my data anywhere, anytime.
That's great. It sounds like Snapshot would be a great tool for data recovery, and also it's good for like distributing data at different places, and also to move your data around.
Exactly. That's why we worked on this very important project.
So I think we just covered the motivation of this project. Now this is the agenda for the rest of the talk. First, we are going to have some background on Kubernetes persistent volumes and storage plugin, and then introduce our CSI container storage interface, followed by a detailed explanation about CSI snapshot design. At last, we'll give 2 little demos. So in Kubernetes, normally we split into 2 worlds, users and system admins. For user, they need to use storage, so they make some request, and admins will help to allocate the storage. And in Kubernetes, it's all about APIs. So there are 2 APIs to represent for users and for admins. For user side, persistent volume claim, PVC, is used to specify what kind of storage and what type and what's the size the user needs, right? And then admin can, based on those requirements to allocate storage, the detailed information will be put in the persistent volume PV API object. And Kubernetes will try to match between PVC and PV, bind them. PVC and PV is 1-1 mapping. Now, in order to reduce system use involvement, and Kubernetes storage support dynamic provisioning by using storage class. So storage class basically, like, you can define policy how you want to provision your volume. And you can specify like what kind of storage is fast or slow, or what kind of amount of options. Now, when user create a PVC, right, system will, based on the storage class, to provision the volume automatically. So admin does not need to do anything. And this diagram shows the volume lifecycle. Like, it includes create, delete, attach volume to node, mount, and mount. And there are several controllers I used to manage it. On master side, we have 2 controllers. PV controller is for what, like, API object creation, deletion, and also for binding the PVC and PV. And the storage plugin will provide provisioning interface. We also have attach-detach controller, like to manage attach, volume to node, detach. And on every node, there is a node agent, a kubelet volume manager, responsible for mounting and mounting the volume to the node. All these kind of controller follow the same pattern. So it's running the loop. It will watch the creation, deletion of API objects, get the desired state, like what the user wants state to be, and compare with the current state and make actions, right, to make current towards to the desired. So for storage plugins, previously, all kinds of storage plugins most likely will be embedded into the Kubernetes big box, right? You can see here. This in-train design does give us some benefit, like it's easy to implement, to manage, but it also gives us lots of trouble. Like includes the storage plugin will tightly coupled with the Kubernetes release cycle, right? So they can only update when Kubernetes update. And also they force storage provider to open source, which is not really ideal. And all the testing burden will put in the Kubernetes. And it also requires some root access to install binaries, which is sometimes not practical.
Yeah, Jing, actually we are not alone. Other CEOs also have similar challenges. In addition, every CEO wants to support as many storage systems as possible, but without CSI, each CEO has its own way to write a plugin, so that means the storage vendor has to write different plugins for different CEOs. Fortunately, we have CSI come to the rescue. CSI is an industry standard to define a set of storage interfaces so that a storage vendor can write just one plugin and have it work across a range of container orchestration systems, including Kubernetes, Mesos, Docker, and Cloud Foundry. CSI is out of tree, so we don't have the plugin tightly coupled with the CO's release cycle. CSI is a gRPC service-based. Also, it emphasizes on idempotency. That means if you create a create volume with the same name and same parameters many times, you should get the same results. You should only get one volume created, not multiples. CSI 1.0 will be available very soon, hopefully by the end of this week. And new features will only be added to CSI. And new features will now be added to in-tree drivers and will now be added to flex volume drivers. There are 3 core gRPC services in CSI: the controller, node, identity service. The identity service provides information and capabilities of a plugin. The controller service supports create and delete volume, attach and detach volume, create and delete snapshot, and it runs on any node. And the node service supports mount and unmount volume operations, and that can run on every worker node. And also expand volume function may be coming soon. There are several ways to deploy CSI plugins. So in this diagram, it shows the plugin runs on all nodes. So we have a controller plugin that runs on the master node, and we have the node plugin that runs on every worker node. Here we have 3 different types of deployments. They are all headless plugins. The top one has the controller plugin and node plugin separate, but they are all running on the worker node. And we also have controller and node plugin together. That is also running on the worker node. And the one on the right-hand side, that only has the node plugin. It does not have the controller plugin. So an example of that would be the NFS plugin. It only implemented node functions, but not the controller side of functions. So we'll be talking about the CSI snapshot design and the volume snapshot concepts in Kubernetes. There are 3 snapshot RPCs: create snapshot, delete snapshot, and the list snapshots. If a plugin supports create, delete snapshot controller capabilities, then the plugin must implement create snapshot, delete snapshot, and create volume from snapshot. And if the plugin supports list snapshots capability, then it must implement list snapshots function. You can call list snapshots to curate the status of a snapshot too, providing the snapshot ID as the filtering. And also we just added the clone volume capability. So if that is supported, then the plugin must implement create volume for another volume. In the create snapshot request, we pass in the source volume ID and the name. Name must be unique. That is to support idempotency. And it has secrets and parameters. Parameters are opaque to the COs. Only the plugin knows how to parse them. And in the create snapshot response, we have the size. So that tells the CO when you want to create a volume from snapshot, your size must be equal to or greater than the size. And we have a snapshot ID. This snapshot ID is generated by the plugin. This is different from the name in the create snapshot request. That one is generated by the CO. So when you call create snapshot, you give the name, and after the snapshot is created, you get a snapshot ID from the plugin. Then you use the snapshot ID to call list snapshots and delete snapshot. We also have a creation timestamp and also a Boolean ready to use. So create snapshot can have 2 steps. Some storage systems support uploading the snapshot after the snapshot is cut. So the create snapshot call is synchronous and blocking until the snapshot is cut. At that point, it returns, and depending on whether the plugin will upload the snapshot or not, if it doesn't need to upload snapshot, it's going to return and set ready to use to true, and then you're done. But if you need to upload snapshot, then the ready to use flag needs to set to false, and upload snapshot will continue in the background until it becomes true. So CO should call create snapshot repeatedly to find out whether this ready to use flag has become true. And at that point, when this ready to use is true, you can create a volume from the snapshot. So in the create volume request, we need to pass in the volume content source that can either be a snapshot source or a volume source. That is the one that is just added to clone the volume. So Jing talked about the PVC in the user space and PV in admin space earlier, and also there's a storage class for dynamic provisioning. For volume snapshots, we have similar concepts. Volume snapshot is a request by the user for a snapshot, and volume snapshot content is the snapshot created on the storage system by the admin. There is a bidirectional binding between the volume snapshot and the volume snapshot content. So when the snapshot is ready, it is bound. And we also have a volume snapshot class for dynamic provisioning. Because a volume may have multiple snapshots, and each snapshot may have a different request, so we use this different snapshot class, not reusing the storage class for the volume. All this volume snapshot API objects are CRDs that makes Kubernetes pluggable and extensible. And the CIDs will be installed automatically by the external snapshotter sidecar container. So this is the volume snapshot API object in Kubernetes. We have a spec and status. A spec describes the desired characteristics you want to have in the volume snapshot, and the status describes the actual state of the volume snapshot. In the spec, we have the source, which is the PVC, and we also have the snapshot content name and the snapshot class name. And in the status, we have the creation timestamp, the restore size, and the ready. We also have a volume snapshot content API object. So in the content spec, we have a reference to the volume snapshot object, and also we have a volume snapshot source, which is a CSI source. And a volume snapshot feature only supports CSI drivers. So when we do the restore, we need to specify this data source object. So we just added this new API object, data source, that can be used for snapshotting and also restore volume from snapshot. And in the future, we can also support PVC type for cloning.
Thanks, Jing, for the detailed explanation about the API spec. Do you have some examples, like how to use CSI Snapshot?
Yeah, sure. I'm going to give some examples. So here we have an example for volume snapshot class. You can create a default class, specifying its default class to true. And then you need to set the snapshotter to your driver name. And also under parameters, you can have the opaque parameters for your driver. There are reserved keys for secret name and secret namespace. If your plugin needs to use a secret to create or delete snapshot, you can use that. And we also have a YAML file for the volume snapshot. You need to specify the snapshot class name and the source. And also, if you are not specifying the snapshot class name, the default class will be used. So to create a volume snapshot, the PVC has to be in bound state, otherwise it will fail. So after snapshot is created, you will get the status, which has the timestamp. And to restore volume from a snapshot, we need to specify the data source. So I hope my examples are straightforward, Jing.
Yeah, it looks like Snapshot is quite easy to use. Let's look at how to manage a CSI Snapshot in Kubernetes and deployment. I just want to check, can you hear us clearly? Is it okay, the background? Oh, okay. So we already see this diagram, right? And we have volume lifecycle and we have controllers. Now with CSI, since CSI is out of tree, and we need some external components to communicate with the out of tree CSI driver. So we have external provisioner, external attacher. And also the CS plugin, right, will communicate with the node agent Kubernetes volume manager. Now for Snapshot, right, we have Snapshot lifecycle management. And it is controlled by external snapshotter. And there are a list of things snapshotters need to do. Similar to PV controller, you need to watch creation, deletion, events of snapshots, and take actions, and also bind snapshot and snapshot content objects. It also needs to make sure to recover from the previous state when it fails, when the controller is restarts. And also we are adding features like to have some protection. For example, to prevent deleting the snapshot while you have a volume is being restored from snapshot, or it prevents deleting the volume while a snapshot is taken from the volume. And also it supports deletion policy. We have two policies, delete and retain. Retain means when user delete a volume snapshot object, but the underlying snapshot will be kept, right? It's still there. And for deployment, so on every node, we'll have a daemon set to run CSS driver as container and also the driver registrar. And they communicate with the Kubernetes volume manager through the sockets. And for controller, we will use a stateful set to run the external controllers, including snapshotter, a provisioner, attacher, right? They can run in a sidecar container. And they communicate with CSI drivers through gRPCs. The controller can run on any node, or it can run on master, like Xing mentioned. The controller will watch the API objects through the API server. And now, CSI Snapshot is available as alpha feature since Kubernetes version 1.12. And we have a handful of CSI drivers already support Snapshot. And we hope the list will getting longer. And if anyone interested in implementing Snapshot, support Snapshot in your CSI plugin, right, it's very simple. You only need to implement 3 controller calls, RPCs. Create snapshot, delete snapshot, list snapshot, so that your plugin have those capabilities. And next step, we're going to have a long list of features we want to implement on top of the current framework. For example, topology support, so that you can specify where you want to your snapshot located at. And currently, the user has to manually prepare the application, to freeze the application before taking snapshot to have the consistency snapshot. So we want to add some pre-snapshot, post-snapshot hooks, so the application can be prepared automatically. And also, we want to have take group of snapshots together and some policy-based management, etc. So the list is getting long. And okay, it's time for our demo. The first demo is WordPress failure recovery. So we have a WordPress and also MySQL installed on multi-zone GCE cluster. And we have 2 persistent volumes. One is for WordPress, one is for MySQL. And we can take CSI snapshot for the MySQL volume and later restore from the snapshot. All the volumes will be stored on the Google Cloud Storage. So Kubernetes doc has this tutorial, right? It's very easy to install WordPress. It includes all the YAML file. You can just copy it. And here in my cluster, I already set it up. So I have stateful set running the MySQL, and I have a deployment running WordPress, and the service is up running. Let's go to the Snapshot website. And I want to create a post, right? KubeCon in Shanghai, and this is really great. So it's really exciting, right, to have a KubeCon here. So I'm very excited to publish this post. Now let's check it. Okay, it's here. Because my post is so important, I want to make sure I don't lose it. I take a snapshot. This is my snapshot YAML file. It's very simple. It's just include your PVC and PVC name, right? Which is the WordPress MySQL PVC name. Now you just use one command line to create snapshot, and you can check right by described snapshot API object. And there are some information you can get from here. Sorry, the typo. Human errors always happen. And you can see, right, in the status, the creation time is set. That means the snapshot is cut. But ready is false means it's still in uploading. It's not ready to be used. And then I'm going to do something wrong. So I leave some bad comments because I plan to do something not very good. So here we can check the volume snapshot. the ready state becomes true, right? It means uploading finish. And I plan to delete the volume, the MySQL volume. And that means I'm going to lose my great post. And after I delete it, I can check the status of the PVC. And you will see the PVC status will become terminating. So it does not delete it completely because actually a pod, the MySQL pod, still use it. So there is a protection. So I then go ahead to delete MySQL stateful set too. So in this way, the pod stateful set will be gone, and also the PVC will be eventually deleted. And now it's time for me to recover, right? So I recreate my MySQL stateful set. So here the pod, MySQL pod is already gone. So I just use kubectl create of MySQL stateful set. The stateful set is created. The arrow is just showing the service already exists because I didn't delete the service. And now the MySQL pod is trying to start. In order to make this WordPress work, I have to restart WordPress too. So here I just delete the pod WordPress. And then since it is under a deployment controller will automatically restart WordPress pod. Let's see, the MySQL volume, right, this is a new volume, is already created and bound. And the WordPress pod is restarted. MySQL takes a little bit longer time to start, but that's okay. Now, let's check the new MySQL stateful set. In order to restore, I do add a few lines here. The data source and the volume claim template. So data source means the volume will be created from this particular snapshot. Your volume is no longer empty volume. Although it still shows the container is not started yet, but let's go ahead to check the website. And you see the comments, those bad comments are gone, but my post is still here, right? My great post is still here. That means I successfully recover from those bad deletions. Okay, that's for my little demo. And Xing will give another demo.
So yeah, I'm going to do a demo of uploading Snapshot. Okay, so I'm going to have a Nginx app running with the volumes provisioned by OpenSTS CSI plugin with the LVM backend. And I'm going to take a snapshot and then upload the snapshot from the local LVM block storage to the S3 object store in AWS. And after that, I will restore volume from the snapshot. Okay, so first log into OpenSTS dashboard. We have a multi-cloud control with object stores from AWS. So we don't have any volumes yet. So we check if OpenSTS CSI plugin is running. So it's running. We don't have any PVC or PV. We only have a standard storage class right now. And we don't have any volumes in OpenSTS. So next, we're going to create a storage class and create a PVC. So PVC is created. We also have the storage class created. And it's also showing up in our OpenSTS database. So we double check that in our dashboard. Yeah, it's there. So now, next we're going to start the NGINX app and make sure that it uses the OpenSTS volume we just created. So now that's running. So we're going to log into this container, and we're going to write something to that volume. So we write this nice message, hello, OpenSTS. So we don't have a snapshot yet. We're going to create a snapshot. So we're going to use this profile to upload the snapshot. So it specifies what is the bucket name where we are going to upload. We're going to create a snapshot class now. And then create a snapshot. So that's created. It's also in the OpenSTS database. So now we check that in our dashboard. So we have a snapshot on LVM, and that snapshot is also uploaded to the cloud. We want to double check that in the AWS UI. Yeah, so it's there. Snapshot is in the AWS S3 bucket. So next we are going to log into the container again. So I made a mistake. I wrote some message there and overwrite my nice message. But fortunately, I have already taken a snapshot, so I can recover. So I'm going to kill the NGINX pod first. So next, we're going to create a volume from a snapshot. So now see the second volume is created. It's showing the dashboard as well. And next, we're going to restart the NGINX app using this new volume. Next, I'm going to log into the container again and check to see if my message is restored. Yes, it's there. So my recovery is successful. That's my demo.
Okay, that's our two small demos. And so it's still like a starting phase. So I'm sure with new features, we are going to support more complex use cases. There are some useful links here, like we have a blog, and we listed our external snapshot repo. We have weekly meeting. You can check our doc for time if you want to join, and some documentations. And this is definitely a collaboration work. So if you're interested, please join us. And those are the contact information. Now, I think that's for our talk. We can have like questions.
两位好，我是之前在那个孵化器里面 incubator 那个 external storage， 我是用的那套，然后我当时在那个事情里面有 raise issue， 然后你给我回复了说，正在往那个 in tray 里面搬，那我停下来，现在应该是搬进去了是吧？
最后的 decision 就是说 out of tray， 因为 CSI 就是 out of tray， 那么我们新的 feature 都会在 CSI 基础上，所有的都会在 migrate 到 CSI， 所以最后的决定就是说不再 in tray 了，那么就是在 CSI Snapshot， 那么就是 out of tray， 所有这一套的话，包括 controller， 包括它的 API 就是 CRD， 因为Kubernetes 现在的趋势就是说like extensibility, right? So it's easy. We don't want to put anything like in tray anymore. So yeah, that's the decision.
还有一个问题就是，那我原先在那个 external storage 里面做的那些定制，就是因为我们有这个需求嘛，做的一些定制，那是不是相应的也要跟着往社区这边往里面搬？第二个问题就是实际的场景，因为我们做这个扩展是业务需求，简单说一下就是 MySQL 类似于这种RDS 每日就是做每日的备份，这样可以做一些灾备的工作。那我们用背后的存储是 CFRBD 这块，就是想请教一下两位，像这种场景作为一个日常使用来说的话，因为 Snapshot 我要备份频率比较高嘛，所以占空间也是会一段时间下来也是会比较大，所以想请教两位这方面有没有什么好的建议？
我们会有 feature like you can like how long you want to retain， 就是 how long you want to keep your snapshot, right? You can specify after that period of time we can automatically delete your snapshot, etc. So those are the features we are considering. And like policy-based management, right? You can define how often, how frequent, and how many snapshots you want to keep. 对，是的，就是，但是这是like future work, part of the future work. Those belong to policy-based management. 那个。
还有一个就是你是用的 SAP CSI plugin 吗？我在想他们有没有可能做那种什么 incremental 那种 snapshot， 就是他们在他 driver 里边做，这也是一种可能性。我是想，对，会有一些麻烦，因为我们因为在外边不支持这个嘛，所以如果说你要 delete 一个的话，就说可能会有些影响。要你 delete 中间的一个的话，对。
Yeah.
Okay, you just said CSI 1.0 is coming this week. So I'm not sure what does it mean by CSI 1.0 because I know CSI includes several sidecar containers and CSI drivers. So what does it mean by CSI 1.0? What does it include?
Yeah, so basically that just means it's more ready, right? So before that, if you're saying it's 0.3, it's not ready. 1.0 means it's GA. So that has the snapshot feature. It has the create volume, delete volume, attach, detach, mount, and the snapshot feature, and also the cloning one was just added. Expand, we're still waiting for that one. That PR, I think it's getting close. It might get in. Expand volume feature might get in. We're still waiting for that one.
Okay, so you mean CSI 1.0 includes several sidecar containers like Oh, yeah, the spike, just a spike. Oh, okay. I got, thank you. Okay, another question is, I'm not sure, I don't understand because currently we use PV controller to manage the PV and PVC object, but it seems like for the snapshot we have no such controllers. Snapshotter. Oh, is the controller. Oh, you mean in the in tray we have a selector.
It's
out of tray.
Because it's CRD, so
Oh,
we
okay.
have out of tray to manage the life cycle.
Okay. Slider. So is it included in the snapshot sidecar containers?
As a system in, they can deploy
Uh-huh.
external snapshotter, external provision.
Okay. So, okay.
Part of the deployment of the CSI.
Okay. Like the external provisioner containers. Okay. Thank you.
你好，我问个问题，就是刚刚看你那个 demo 1的时候，就是你那个失败那个恢复，它是自动的吗？还是说你要去修改那个 data source？
Right now it's manual, so you have to put your data source by yourself. So that's kind of work we want to have some automatic way, right, to be able to. But right now it's still like a manual process.
也就是说你现在是手动的，但是以后有自动的计划，走自动计划。那还有另一个问题就是说，那你后面要做的那个 revert 那个功能，那revert 的功能的话，其实就是说你用户想主动的去把这个数据盘给回退，是这个意思吗？是这个功能。那还有另外一个问题就是说，这个快照以后会有支持版本的这样的一种功能吗？就是说我回退到哪个版本的快照，有这样的计划吗？
I don't think we discussed that yet, but like as a user, right, we like hear your feedback, and if you have some use cases, we definitely will consider to support if it's like a very useful use case. So you mean like you have several versions of snapshots, right? And then so right now you can just manually you can do that. You just pick okay which version you want to restore back, right?
One more question. 就是那个会不会支持策略？就是说我什么情况下我要那个让那个就是快照来覆盖我原来的盘，有没有支持这种策略的想法？就是现在都是，比如说现在是手动，然后你们下一个版本支持自动，对吧？后面会不会加上策略？
Like make the smart choice, like by the system itself, or you define some policy in what scenario it's like. I think that's definitely like a good direction to automate, right? But we need to build up like all the features. Right now is very basic, right? You can see so all those advanced feature like 更加那个高级的就会一点点，但是不是说一下子就全部都能做成的，就是我们有 roadmap， 但是像刚才提到那些在 roadmap 里边，然后有一些像你提到的可能没有完全就是 address。那么就是说，如果我们会你参加我们的 meeting 啊，然后如果你有需求，我们可以就是交流，对，没事。
It seems you guys want to do something in data retention area. I mean, this is the data retention is a full stack, right? Underlying devices, maybe object storage or traditional block storage, and the snapshot layer or your CSI layer. But the upper layer for the backup software, for the data retention, for backup archive. I think it's a very specific domain for some today traditional area like Veritas, right? Like EMC, backup software. So will Kubernetes will this community cover all stack or just give a reference example and let ecosystem get built up. I'm not sure what is the community strategy.
So right now, I think the plan is at first build the very basic functionalities and also based on the requirements and build some a little bit more advanced features. But I don't think we can replace like the whole stack or anything. So it definitely needs some like it's not a full replacement for like data backup or anything. But we can try to provide some like common use case, right? And so have some features, and so user can kind of customize and also have their own solutions for their data, yeah, retain policy or something, yeah.
Can CSI support block device, no file system, and pass it through into container? Any
Yes.
use case?
Yes, it does. Yeah, it has. We have a alpha support for that. You can actually specify the volume mode as block. Then you can expose the raw block device to the container. Yeah, that is there. So the use cases, of course, are some of the database applications use that.
你举的例子全是那个就是 safe 类的，这就是 external 的这个PVC 这种例子哈，是支不支持 local persistent value， 就本地的持久化卷，完了之后呢到 external 的这种 snapshot， 还是只支持这种 safe 类的 snapshot？
As for now, I think it's not local, but yeah, as for now. But again, like we can, if you need. I don't think so. There. I don't think it's a big difference. Like some use cases may need external volume, like external storage. Some need local storage, but the whole like framework you can see is not like very different from local or remote. So I don't think it's right now we don't support, but it doesn't mean we cannot in the future. Yeah.
谢谢。其实我想问一个问题，就是你们对于 failover 这块disaster recovery 这块是怎么看的？以及社区有没有 plan 在未来去做这件事情
I think Snapshot is a start, like it's the first step, and but to be able to like have a full stories about data recovery, disaster recovery, it needs not only Snapshot but everything like relevant, yeah.
那我再追一个问题啊，就是说，如果确实有这样的计划的话，能不能告诉我们你们大概有一个什么样的想法，会去做这件事情？就是 CSI 这块会 cover 到多少？其实我的问题和刚才那位那个先生问的差不多，就是我知道 CSI 肯定会希望 cover 很多东西，但是我们传统的 Unix 的想法是 keep it stupid and simple， 所以说就是我们想知道的是 ecosystem 可以能够做些什么，包括像 disaster recovery 这块也是这样子的。
实际上那个就是 disaster recovery， 现在你已经可以在那个 drivers 那层次已经可以做了，像我们那个 OpenSDS plugin 已经可以支持 failover 了，就是你上面那个 PVC level 你就是一个，就你认为它是一个卷，但实际上下面是一个 pair， 你下面你的 driver 可以管理2个卷，这已经是可以做到的事情了。
在我的理解，就是 disaster recovery 应该不会只是在卷这一层去做，因为这只是数据层。我相信绝大多数的客户会希望说，我能够在 application 层面也能做到。所以我想问的就是说，这种 CSI 的 disaster recovery 的设计是只是在 CSI 层面来做，还是到时候 Kubernetes 也会被包含进来？或者说其他的 orchestrator 也会被包含进来？我想问的是这个问题。
我感觉就是目前还是在讨论当中，就是说这个 snapshot right now 就只是在 volume 那一层，对吧？然后我们有一点点想法，就是说，比如说 snapshot 不光是说只是针对 volume， 可以是一个 part snapshot 的一个 stateful set snapshot， 然后 recover from like back to pod, back to stateful set, etc. 但是这些还在 early discussion， 就是至于做到就是说什么样一个程度，还没有一个什么定论。因为我们刚刚这个 snapshot alpha feature， 然后就是要根据这个需要，然后我们能做的可能是一些 common 的 use case， 不会说 cover 那么全部的。然后所以现在的话，有一些比较基本的functions features。We want to like 我们想先做，那么就是更 advanced 的话还没有就是说讨论的那么清楚，对。
Does the CSI supports both ISCSI as well as FC?
What? Can you repeat your question?
Does CSI supports both ISCSI protocol as well as FC protocol?
Yeah, and there is actually, well, I think that driver is actually still being worked on, so it's not, there is a basic one, and then there is some refactoring going on that one, but it should be available soon for ISCSI. Yeah.
Okay. And while recovering the volume from the snapshot feature that we are implementing in the CSI, like we have different states of the PVC, right? It can be in creating and claimed state or bound state. So the use case here basically is when your volume is deleted and you want to recover it from the snapshot. The recovering may take some time. So how long this kubelet will kubectl will wait for the response from the daemon, or at what point it will take the decision like whether it is recovered or not? How do we decide that, or how does the CSI decides on this?
So right now, if you, as you can see in our demos, right now it's still a manual process because we have not make all of the restore process automatic yet. So right now, actually, you have to go there and change your YAML file to specify that you are actually create a volume from a snapshot source, right? So that's actually, it's not automatic yet. Yeah, so you do have to.
Yeah, so my question here is like we are creating a PVC only, right, when we are recovering a snapshot. So what I mean is like it will be in a creating state or it is in a bound state, right, when we create a volume or when we create a PVC. So for the snapshot to be recovered, it has to be completely moved complete data from the original snapshot to the volume that we are creating. So until we finish this step, it might take, suppose we have 100 gig of data and it will take a huge lot of time, right? So how does the vendors or the CSI will take care of this? That is what my question is basically.
Like, how long it will take, how long it will time out.
Yeah, so to make it from the creating state to the bound state, how do we decide that?
So right now there is in the CSI driver, when you start it, there is a place where you can actually specify the timeout value, like how long you want to wait.
Okay.
Yeah.
So we have the timeout value.
Yeah, you should be able to control that. Yeah.
Yeah.
But if something's missing, definitely open an issue.
Thank you. 我第一个问题其实是想说，就是现在 CSI 的看起来的范畴主要还是 cover 这个block 和 file system 这两块，就是后续那个对象存储的会整个丢给会和数据库一块丢给 API 那一块去覆盖，对吧？是这样吗？
现在反正确实没有直接的那个对象的这种接口，但是现在有一个 feature 就是 cloning 那个 feature，就是刚才说那 cloning feature。它是有可能用那个 S3 的一个 data source 的，就是它可以把那个数据从那边给 download 下来，然后 create 一个 PVC， 这是以后是有可能的。
就是这个 feature 我看了好像是在你那个 OpenSDS 里面去做，就其实是在driver 层去把它备份到一个 S3 的 storage 嘛，对吧？
这 OpenSDS 是有，但是就是我们现在那个社区里有一个这个 cloning 的这个 feature， 就是现在。还正在比较初期的阶段
，OK，
所以我们有把它先加到这个 CSI spec 里来，然后下一步就是说，在 K8 里你会看到有那个 design spec 会有一些 discussion，
所以另外一个可能是跟您那边那个 OpenSDS 的项目可能比较相关的，就是说其实前面也有同事有问到，所以可以看到就是说关于容载的一些高级别的特性，可能是更多的体现在就是您那个 OpenSDS 的项目里面，比如说备份以及就是底层的这种 PV 的一个双活，对吧？然后这种特性其实您也是期待让 CSI Driver 去实现，对吧？就是底层的存储厂商去做这个事儿，对吧？
就这件事情我不能说我就能够完全做决定，是吧？但现在其实明天我们有一个那个Strategy Working Group Deep Dive Session， 然后那个时候会说一下，就是比如说像 CSI 啊，像这些 driver，主要是 focus on provisioning， 然后还有一些更高的那种 advanced function， 那可能会有另外的一些 project 去做。
OK，
就是。
谢谢。
我请问一下，那个 CSI 它那个 controller 部分，它有没有高可用的方面的一个设计吗？
什么设计？
就是可用性方面，就是你的 controller 的那个 pod， 如果意外情况下如果被删掉了，有没有一个就是多个节点高可用，就是关于 HA 这方面的设计？
它有一个那个 leader election， 有那个我们的 snapshot 现在那个还没有合进去，但是像 external provisioner 还有 attacher 都有那个 leader election。
那么如果那个像 provisioner 和那个 attacher 和 snapshot 都在同一个那个封装在同一个 pod 里面的话，它那个选组到底是怎么选？就是选的是哪一个 pod 呢？就是你们是选组好像是在容器层面在选，然后但是使用的方面会从 pod 方面来看它的高可用性。我想到这么一个问题。
应该是 pod 呀，一般就是你挂载的时候，你都是那个一般都是 pod 嘛。
像那个 provisioner、attacher 和那个 snapshot 里面都有这个选组的代码，对吧？选组就是 leader election 那个，对吧？但是在这个容器里面会有一个选组啊。但是
就是在 controller 它有 leader election，external provision 那个都是 sidecar container， 那个都是一个 controller 嘛，还有那个 external attacher， 那里头都有。
我知道是在那个 provisioner 这种的容器里面，但是如果把这三个 sidecar 容器就合成一个那个 controller 的 pod 里选组的情况下，就是
你要是 deploy 的时候全部 deploy 在一起啊。
对。
那就只能是还是
还是要分开，
那样可能会比较麻烦，对。
那
样可能是分开的 deploy 会比较好一点。
还有刚才那个在那个 step set 那个例子上面的时候，下面是多了那个什么 data， 就是 restore from snapshot 这个特性。那如果没有这个 snapshot 的话，它创建那个PVC 的话，就是一个空的 PVC 嘛。OK。
好，非常感谢。如果大家还有问题的话，我们可以在 offline 讨论。谢谢大家。